This video is on solving quadratics by using the quadratic formula. We're actually going to talk about the discriminant on this video. The discriminant actually determines how many and the type of solutions you're going to have before you even solve it. You can actually determine how many solutions you're going to have and then the type of solution, so you know how the graph will look if you don't graph it. The discriminant, the value of the discriminant is the b squared minus 4ac. And here's the quadratic formula. We derived it in a previous video. The discriminant is the part that's underneath the square root symbol. So it's b squared minus 4ac. Notice that the square root is not on this because the discriminant is the value inside. It's your radicand. It is your radicand value. So if b squared minus 4ac is a positive perfect square, it's very specific here, positive perfect square. So it's not only is it positive, but it has to be 1, 4, 9, 16, 25, 36, any perfect square, because you could take the square root of it and be a nice perfect number. So if it is a positive perfect square, how many solutions you're going to have? You will have 2 solutions. You're going to have 2 solutions. Now the type of solutions, there's actually 2 ways we can describe it, and you need to make sure you understand which 2 ways they are. Because it's going to be a positive perfect square, you will have 2 real answers because you can take the square root of it, and they're going to be rational because you can take the square root of it. Because the square root of 4 is 2. The square root of 25 is 5. It won't give you a decimal answer. So if the square root, you can take the square root of a positive perfect square, you'll get 2 solutions, and they will both be real answers, so they won't have I on it, and they'll both be rational solutions, so they'll cross at nice, clean numbers, like 7 is perfectly fine. So an example of the graph of this related function, so if we were to graph this, we'd still have all of these will have our x and y on it. So I'll go ahead and actually put x and y on all of these. X and y, x and y, x and y. I'm not going to focus on the count by on this one because we're not actually graphing anything. This would be a parabola that crosses through the x-axis twice. And again, it could cross on both negatives, it could cross both positives, or one of each. But these 2 solutions here would be nice, clean numbers. Like this could be a x equals a positive 2, and this one could be x equals a negative 4. They would be nice, clean solutions. If b squared minus 4 is a positive but a non-perfect square, so it's still positive, but it's like 3 or 5 or 7 or 8, you are still going to have 2 solutions. So we're still going to have 2 solutions on here. You can still take the square root of it. It'll just be a decimal. So if you can take the square root of it and not have an error, that means you will have still real solutions. You'll have 2 real. And the problem is that if it's a positive non-perfect square, so again, 8. If you took the square root of 8, you would get a decimal. And it would be, you could not turn it into a fraction, it would be an irrational number. An irrational number. So the square root of 8 would be a irrational number. So if we were to graph this, it would still cross through the x-axis 2 times. You could see it cross 2 times. However, the 2 solutions could be something like x equals the square root of 3. And then it would also give you, if you had the positive square root of 3, the other one would have to be negative square root of 3. If you have positive square root of 3, you also have to have the negative square root of 3, because it'd be the plus or minus square root of 3. Same thing if you had square root of 5. If this was square root of 5, this one would have to be negative square root of 5. On this next one, if your discriminant, b squared minus 4c, is 0, so if you plug in your b squared minus 4c and you get a value of 0, how many solutions you would have? You would just have one solution. Technically, it would still happen twice, but when that happens, when you have just one solution, that goes back to understanding that it's going to bounce off of the x-axis. So, the type of solution, it will still touch the x-axis, so that means it's still going to be real. And now, the thing about 0 is you can still take the square root of 0. What times itself gives you 0 is 0, so you have an answer. It's not a decimal. So this would still be real, and it would also be rational. So it's real and rational. Because square root of 0 is 0, so it's perfectly fine. So you'd have one real, rational solution. What that means, again, going back to previous work that I've explained, is that this quadratic would touch the x-axis. It wouldn't cross through, but it bounces off the x-axis. Again, it doesn't matter if it's on the positive, the negative, or on the 0. But this solution could be something, a real, rational. So it would be x equals, a rational answer could still be 1/2, because that's still a rational answer because it can be written as a fraction. So that is still a rational answer. You could also have it as 4, as 8, as negative 3. It does not matter as long as it is still rational, but you only have that one solution. Now the last thing you could have for the discriminant is b squared minus 4ac is a negative. Does not matter if it's a perfect square, does not matter if it's a non-perfect square, but if this value is negative, that means that the parabola does not cross the x-axis. Because remember, this part, b squared minus 4ac, is the part that's inside the square root. That's your radicand. So your radicand, your discriminant, is your radicand. You can't take the square root of a negative in your calculator, but you could still do it by hand. You would still have two solutions, but they would be imaginary, because you'd have to end up taking out that I. Imaginary. Now, I cannot say rational or irrational on here because they're imaginary. This is the only way you can have imaginary. It's just too imaginary. So it's neither rational or irrational because it's just imaginary because of the I. So again, the graph of this would just be a parabola, and it does not cross the x-axis at all. So you'd have two solutions, but they do not cross. So you don't have actual x-intercepts. So again, the discriminant is the radicand of the quadratic formula. And before you even begin the process of solving, you can determine how many solutions you're going to have, and if they're going to have an I in it or not, and if they're going to have a square root symbol, because this one will still have a square root symbol in your answer, and these won't. So you can actually determine that before you begin, and then you can check to see if your answers are correct based off of what you determined your discriminant was.